wasn't. For me, it was 5 hours. See, the rules of the quantum realm aren't like they are up here. Everything is unpredictable.
What Scott said in physics is called the uncertainty principle, something that made Einstein hate quantum physics so much. That he said his famous quote, "God does not fly dice." Why is that? That's what I'm going to discuss. What's certain is that quantum physics restates scientists in Einstein time. Just like Dr. Strange when the Ancient One opened his third eye, they were shocked because the universe wasn't what they thought it was.
Open your eyes. Everything we call real is made up of things that cannot be themselves regarded as real.
An odd, mysterious uncertainty at the heart of nature, something that Albert Einstein fought for years to disprove.
If you can explain this using common sense and logic, do let me know, because there's a Nobel Prize for you.
Hi guys, this is part 2 of our discussion about Ant-Man quantum world. In that video, I explained that the quantum world is the subatomic world, or the world inside atom. I already talked about atoms, how they are modeled like this. Inside them, there are electron, proton, and neutron. It's on this level that Ant-Man shrink and enter the quantum realm.
You would go subatomic.
What does that mean?
It means that you would enter a quantum realm.
In that video, you also learned the shocking fact that atoms are empty, because the distance between electron and the atomic nucleus is so far.
If the nucleus were the size of a football, then the nearest electron will be in orbit half a mile away. The rest of the atom will be completely empty space.
And now, today will be even more shocked, because this particle may not even be real.
The problem is, it's a lie. It's a white lie. It's a white lie that we tell our children because, we don't want to expose them to the difficult and horrible truth too early on. It makes it easier to learn if you believe that these particles are the fundamental building blocks of the universe. But it's simply not true.
So does that mean everything you learn about atom in school is wrong? Is it a conspiracy? Watch this video till the end so you understand the context. Later, in quantum physics, atoms aren't represented like this anymore, but like this, more abstract and with many shapes. That's why when Ant-Man entered the quantum realm, its world was depicted as abstract. Why is that?
A place where the laws of physics, space and time themselves, the arrow of time, right? They don't have any meaning. They haven't emerged yet.
The word quantum comes from Max Planck, the very first scientist to propose quantum theory, which earned him Nobel Prize in 1918. His name was even be used for the small scale, the Planck scale, which Tony Sharp once mentioned.
Anything really
Quantum
impossible
fluctuation messes with the Planck scale, which then triggers the Deutsch proposition. Can we agree on that?
So how did Max Planck discover quantum theory? Here's the story. In the early 1900s, there was a huge problem in physics that no one could solve, something called the ultraviolet catastrophe. Wait, was it called a catastrophe? Let me explain the black body radiation first. Don't focus on the word black, focus on the radiation. You know that hot object emit light, right? And the hotter they get, the color shift from red, orange, yellow, and finally white. In physics, this means a shift in wavelengths. Scientists back then tried to find a formula that related radiation, temperature, and wavelengths. The result was a formula known as the Rayleigh-Jeans law. But there was a problem. The formula failed. It predicted that radiation from hot objects would increase infinitely as it approached ultraviolet frequencies. That's a disaster. Because if the formula were correct, you wouldn't be able to sunbathe under sunlight. You'd still burn because of infinite radiation. That's why it was the ultraviolet catastrophe. Luckily, that formula was wrong. In reality, based on measurement, there's a maximum limit to how much radiation a hot object can emit. That's why you don't see blue or violet in flame. Those colors correspond to ultraviolet frequencies, which are too high for normal heat. That actually protects us, because even the sun, which is extremely hot, only emits about 10% ultraviolet radiation, and only 1/3 of that 10% actually reaches Earth. This phenomenon could be explained by classical physics, until Max Planck came up with a radical idea. He thought, maybe our understanding of light is wrong. He proposed that light isn't continuous, but made of tiny packets of energy, which he called quanta. From this word came the term quantum, which became viral among scientists at the time. With this assumption, Planck was able to fix the Rayleigh-Jeans law, so that it matched the experimental result, and that's why he received the Nobel Prize. Planck's discovery helped Einstein solve another mystery, the photoelectric effect, which later became the basis of solar cell. He wanted to know why light could generate electricity, but only depending on its wavelength, not its brightness. For example, yellow light, no matter how bright, couldn't move electrons easily. will dim blue light cold. Inspired by Planck's quanta, Einstein thought this can only happen if light acts as a particle, which he called a photon. He solved the problem and also won the Nobel Prize. The discoveries of Planck and Einstein confused the physics world because light had always been thought of as a wave, not a particle.
Albert Einstein was an early pioneer of quantum theory. He showed that light exists as tiny quantum particles called photons.
What made it worse? Electrons behave the opposite way. What we thought were particles saw wave-like behavior. Einstein wrote, "Sometimes we use one theory, sometimes another. Now we face a new problem. We have the contradictory picture of reality. Alone, neither fully explain the phenomenon, but together they do." This became the concept known as wave-particle duality, the core of quantum theory, and is one of the hardest concepts to understand logically. To grasp how confusing this formula for scientists, think of it like this. A particle is something physical, like a ball, a car, or anything tangible. You can measure a physical thing using Newton's law that you learned in basic physics. But waves aren't physical, they're just disturbance traveling through space. For example, your smartphone catches electromagnetic wave, commonly called signal. Are signals physical? No. The wave can't be measured with Newton's law. They are totally different. In short, particle are matter, waves are not. It's like comparing body and soul in religion.
There is no such thing as spirit. We are made of matter, nothing more.
So how could an electron or photon be both matter and not matter at the same time? To test this wave-particle duality, scientists conducted the famous double-slit experiment. It was first done by Thomas Young in the 1800s to prove that light was a wave. To understand it, think of water wave passing through two slits. The waves split, collide, and create interference. With the peak meet peaks, they amplify. When peaks meet trough, they cancel out. The result is a pattern of alternating light and dark band, called an interference pattern. Thomas Young did this with light and captured the result on screen. The same interference pattern appeared that proves light is a wave. Now, imagine light as a particle.
Yeah, now what you're going to do is you're going to blow through this tube, and here is sand.
Let's throw a handful of sand through two slits. You'd expect two stripes, right?
There are two stripes, very much like the two slits. Because of course, sand consists of grains, like little particles, and they either go through one slit or they go through the other slit. And that's what you're seeing.
So how could particle create an interference pattern? It made no sense. So scientists changed the setup.
What if we were to not send the atoms all through at once, but send them through one at a time?
Here we have the source of light over here.
They fired one photon at a time, ensuring the collision. And here's where things got weird.
This is light traveling through this, but it's arriving as blips, like the sand, as particles. But have a look at this. If we collect up all these blips, collected over a time period, and have a look at what the pattern is, we see something quite remarkable. The pattern you see is the pattern that waves make.
Even when fired individually, photons still created an interference pattern, meaning each photon somehow went through both slits at once, interfered with itself, and became one particle again when hitting the screen.
How does one atom do that? Does it split in half? Does it become like a cloud that goes through both?
Because remember, to make that pattern, that wave pattern, there've got to be two sources, two slits. The light's got to go through both slits.
They repeated this with electrons, and the result was the same.
This is the essence of the weirdness, of the spookiness in the quantum world.
But scientists weren't satisfied. They wanted to know which slit each particle went through. So they put detector by the slit, and guess what happened?
But of course I've been cheeky here. I haven't shown you the results of the experiment.
The interference pattern disappeared. Only two lines appeared, exactly like sand. Scientists were shocked. How could simply observing the particles in the interference pattern vanish? Every time they use a detector, the wave pattern disappeared. When they remove it, the pattern came back, as if the particle knew they were being watched. It's just like Toy Story. The toy moved when no one watching, but freeze when human look.
So here's the last bit of sneakiness that we can play with atoms. Surely now, we're going to get to grips with it. Leave the detector there, but just very quietly go and unplug it. Don't let the atoms know that you're not spying on them. Make them think that you're still detecting them. So, yeah, okay, we're going to run the experiment. Atoms, okay, get ready, one at a time. We're going to be checking on you. All right, so run the experiment again. Now, if you can explain this using common sense and logic, do let me know, because there's a Nobel Prize for you.
Scientists were stunned. It was as if there was a veil separating us from the quantum world. Photon and electron only became real when observed. Otherwise, they exist as abstract waves. Philosophically, this has a serious implication. Remember, these particles make up atom, and atom make up the universe. So if particles are abstract until observed, then reality itself may depend on observation. Something exists because we see it. If we don't, it might not exist at all. Einstein couldn't accept that. He famously asked, does the moon still exist when we are not looking at it? But Niels Bohr, known as the father of quantum mechanics, replied, everything we call real is made of things that cannot be regarded as real.
See, the rules of the quantum realm aren't like they are up here. Everything is unpredictable.
If you can explain this using common sense and logic, do let me know, because there's a Nobel Prize for you.
This is the essence of the weirdness, of the spookiness in the quantum world.
This strange phenomenon drove scientists crazy. How would they describe this in physical terms? Eventually, they had to accept that the quantum world holds different laws. According to Heisenberg calculation, it's impossible to measure both a particle position and momentum precisely. This became the uncertainty principle. In 1927, all Greek scientists Einstein, Planck, Bohr, Schrödinger, and Heisenberg gathered at the Fifth Solvay Conference to discuss these findings. Two camps formed, Einstein's and Bohr's. Though they were frank, they disagreed. Einstein said God does not play dice. Why? Because he rejected Bohr's idea that quantum theory was final, that the universe is inherently random and unpredictable. Bohr believed that the quantum world is truly probabilistic, based on Heisenberg's uncertainty and Schrödinger wave equation. That became known as the Copenhagen interpretation. Einstein didn't like it, saying, God does not play dice with the universe. Bohr replied, Einstein, stop telling God what to do. Their debate became legendary, making the birth of quantum physics itself. Scientists split into two camps, Bohr's and Einstein's. Most sided with Bohr, while Einstein continued trying to prove him wrong. Einstein's, along with Boris Podolsky and Nathan Rosen, later published a paper showing that they thought was a flaw in Bohr's view. They introduced a paradox, now known as the EPR paradox, from their initial, Einstein, Podolsky, and Rosen. The paradox gave rise to what we now call quantum entanglement.
It's quantum entanglement between the quantum states of Posner molecules in your brains,
which Einstein described as spooky action at a distance.
The one thing that Einstein thought was impossible, spooky action at a distance, actually happens.
This is the essence of the weirdness, of the spookiness in the quantum world.
Or more simply, scientific magic. So in the next video, I'll be talking about scientific sorcery.
It is impossible to even comprehend. Don't even ask me why. Don't ask me how it works, because it's an illegal question.
So Earth has wizards now.